Okay, let's get some basics of inequalities out of the way. Inequalities are much like equations, except that the two sides may not be equal to each other. So, for example, if you see this symbol, that symbol means is less than. If you see this symbol, that symbol means is greater than. And if you see a less than with a line underneath it, that means is less than or equal to. So it could be less than or equal to the number. If you see a greater than with a line under it, same basic thing, is greater than or equal to. Okay? So some basic ideas. Real quick, so if you see something like c, some variable c, is less than 5, that's also the same thing, right? If c is less than 5, that means c is smaller than 5, then 5 is greater than c, is bigger than c. So you can see how you could look at this either way. Just be sure that the statements both make sense. If c is less than 5, then 5 has to be greater than c. Now, it might be more beneficial to think about, if you see this, what does that mean? 5 is greater than c. What does that tell us about c? Well, c is less than 5, so you're more apt to go from this to this. Okay, because if you know that c is less than 5 and you wanted to draw that on a number line, you'd mark 5. C is anything smaller than 5, anything less than 5 but not including 5, so we'd put an open circle, and that's a picture of what this inequality means about the variable c. Alright? Now we basically solve inequalities like an equation, right? It has two sides, we need to keep it balanced. So I'll have other videos discussing some of the technical details, but in general, what you do to one side, you have to do to the other to keep the inequality balanced. And so I'll do a few small examples here. So here I want to solve and graph the solutions for this inequality on a number line. So just like an equation, I'd be trying to solve for x, subtract 3 from both sides first, keep the inequality symbol, divide both sides by 2, and you can see that x is less than or equal to 1/2. So on a number line, we're going to call this spot the number 1/2. We know x could be anything smaller than 1/2 or equal to 1/2, so we'll put a shaded circle here. Okay? So what we're graphing when we do this is all the values that x could be, whatever the variable is. This number line represents all the values that that variable could be to make this a true statement. If you plug in any number equal to 1/2 or any number less than 1/2 into the original inequality now, it would be a true statement. You could verify that on your own. Now this one's a bit trickier. Negative x is less than 4, and so you would first think, well, this is like -1 times x, so divide both sides by a -1. Well, before we do that, we have to be aware of something. The left side of this, negative x, means the opposite of x. Okay? So the opposite of x is less than 4. So let's look at what that looks like. So the opposite of x is here, right? Any number smaller than 4. Remember, we're trying to solve this for x. So if the opposite of x is smaller than 4, that means x can't be -4 because the opposite of -4 is 4, and the opposite can't be 4. But x can be anything bigger than -4. So if you look at this, what happens when you divide both sides by -1 in this case? You get x on the left side, you get -4 on the right side, but this less than becomes a greater than, right? Because everything flips around when you do opposites on the number line. Less than 4, opposite of that is bigger than -4 on the number line. So when you multiply or divide both sides by a negative number, flip the inequality symbol. That's the tricky part about inequalities.